Well, thank you very much, and it's very nice to be here and have the chance of talking to you for a while. Then perhaps we'll have a little conversation. People are sometimes...
Direct the microphone a little bit more toward you.
Okay. Okay. Everybody hear me? It's very irritating if you give a talk and at the end people say at the back, I couldn't hear a word you said. It makes for a restful start for the day, but it's not probably what you came to do. Well, here I am. I'm somebody who's a physicist and I'm also a priest. And people are sometimes surprised at that combination. They look at me with the sort of wild amazement that one might look at a centaur, really, which you know is an unnatural mixture of a horse and a man. But I think it's a perfectly natural mixture to have. You see, there's a thought around in the world, which is a gravely mistaken thought, that here is science, which deals with a world of fact, and which gives you true knowledge. And here is religion, which deals with a private world of opinion, in which the best that you can say is, it's true for me, or it's true for you, but it's not just plain true, pure and simple. Now, I'm absolutely certain that that division between the public world of scientific fact and the private world of religious opinion is completely mistaken. We live in one world, and we are seeking the one unified truth about that one world, and if we're going to achieve it, we need the insights both of science and religion. And in fact, they are much closer to each other than people normally recognize. And let me explain why I think that. First of all, for sure, science deals with a world of facts in one sense. But it always deals with a world of interpreted facts. Science doesn't just sit there and watch the world go by. That's called natural history. You can sit in your bird hide and watch the birds go by, and that's a very worthwhile thing to do. But science begins when you look at the world from a point of view. Science always deals with interpreted facts. And once you have interpretation, then a particular point of view is bringing out the significance in the facts that are placed before you. I remember very vividly, as a young man, after I'd done my PhD in Cambridge, I came to the States for a year to work at Caltech, to work with a very famous American theoretical physicist called Murray Gell-Mann, who was the sort of great theoretical physicist of my generation. And I came one day upon Murray, and Murray looked very excited, and he was looking at a photograph. And he said, look at this, and he showed me the photograph. The photograph, there it was. There were just a lot of lines all over the photograph. Those were the facts, plain and simple, and absolutely puzzling and uninteresting they were. But then he produced an overlay, which had been, the photograph of course accompanied the experimentalists, and he produced an overlay that they produced, which repeated those lines, but identified what they were. This line here was a proton, that line there was a pi meson, and so on. And when you saw that identification, when you saw the interpretation, you said, gosh, this is the first photograph that has ever been taken of the decay of what in the trade we call an omega minus particle, a triply strange baryon. And a triply strange thing is very strange indeed, I can tell you that. And that was tremendously exciting because in fact Murray Gell-Mann had predicted the existence of this particle, and its confirmation in that way eventually led to his being awarded a Nobel Prize. But you see, it was the interpretation that made that photograph come alive. Science deals with interpreted facts. So that moves it a little bit nearer religion, but also religion deals with motivated belief. Religious faith doesn't involve shutting your eyes and gritting your teeth and believing 6 impossible things before breakfast. We have reasons for our religious belief. When I had a very interesting sort of period in my life when it was known that I was going to leave physics, but I hadn't yet left it. I couldn't go straight away. I had lots of graduate students, and I couldn't just say to them, cheerio, I hope you get a PhD. I had to sort of wind up my academic affairs and look after them. So I had a period of about 18 months. People knew that I was going, but I hadn't yet gone. And I worked in elementary particle physics, which was a sort of international village. We all knew each other. And so people would say to me, John, what are you up to? and why do you believe in all this religious stuff and so on? And I would know what I had to say to them, or try to say to them. I had to explain to them that there were reasons, there was evidence for my religious belief. I had to speak to them of the figure of Christ. I had to speak of his strange death and his resurrection. And I could do that because my religious belief isn't just a question of believing it because the church tells me so or the Bible tells me so. Of course, the church and the Bible play an important part in my religious life, but in the end, I believe it because I believe I have grounds, motivation for that religious belief. So science deals with interpreted facts, religion deals with motivated belief, and instead of them therefore being a million miles apart, they are much, much closer together. They are parts, different ends no doubt, of a great spectrum of human, rationally motivated inquiry into the way things are. And that's what I mean by saying that I believe that science and religion are cousins under the skin. And I bring to my theological reflection many of the same sort of characteristics that I used in my 25 to 30 years working in theoretical physics. So, not only are they cousins under the skin, but they are complementary descriptions of this one rich world of our experience. The difference between them is not that one is reasonable and the other is irrational. The difference is simply that they are looking at different aspects of experience and they are asking different questions about that experience. Science, essentially, is asking the question, how do things happen? By what means, by what process do things come about? Religion is asking a different question, I think actually a more interesting question. Why are things happening? Is there some meaning and purpose in what is going on in the world? Now, we're perfectly familiar with the idea that we can both ask and answer both of those questions about the same set of circumstances. Not only we can do that, but if we're to understand what's going on, we need to ask and answer both of those questions. Let me give you a rather simple example. I used it, if you'll excuse me, I used it with some groups of high school people I was talking to yesterday, but we shouldn't despise simple understandings. Suppose you were to come into the kitchen of my home back in Cambridge. I live in actually a very beautiful, I've had the privilege of living in a very beautiful President's Lodge in Queens, and the oldest part of the President's Lodge was built in 1450, 42 years before Columbus discovered America, is what I usually say at this, this point. But we have moved with the times. We have modern conveniences, and we have a kitchen which has in it a gas stove. Now suppose that you come in and the kettle is boiling on the gas stove. I place my scientific hat on my head and I say to you, the kettle is boiling because the combustion of gas generates heat. The heat is conducted through the base of the kettle. That raises the temperature of the water, and when the temperature gets to 100 degrees Celsius, a phase change takes place. That's the physicist's way of saying it boils. Now all that is absolutely true and in its way worth knowing. But having said that, that doesn't stop me taking off my scientific hat and turning to you and saying, the kettle is boiling because I wish to make a cup of tea, and would you like to have one? You see, the first answer is an answer in terms of how things happen, if you like, the mechanism by which things come about. The second answer, in terms of my intention to make a cup of tea, is an explanation in terms of purpose. And if you're to understand what's going on in that rather simple and trivial experience of the kettle boiling in my kitchen, you need to know the answer to both of those questions. One is the scientific question, how things happen. The other is the religious question, is there a meaning, a purpose, an intention behind what's going on? So we need both science and religion if we're to understand the world in which we live. They ask different questions, but of course they are not completely independent of each other, because the way you answer one question relates to the way you answer the other question. There must be some consonance, there must be some appropriate relationship between the answers that you give to the question how and to the question why. If you were to come into my kitchen at home and I were to say to you, I have just put the kettle in the refrigerator and would you like a cup of tea, you would doubt the genuineness of my offer. So, first thing I want to say is that we need both science and religion to understand the world. Both deal with motivated belief that arises out of our interpreted experience. that they're asking and answering different questions about the world, but because the answers to those questions must relate to each other in some sensible and appropriate way, they do have things to say to each other. And so I want to go on now to say a little bit about what I think is a conversation, a dialogue, which is going on today between our scientific insights into the world and our religious insights into the world. And I want to suggest, in fact, that conversation between the two is not only very active today, but is also very fruitful and encouraging to both sides. So let's start with a question which many people think is the point of intersection between science and religion, namely the problem of origins, the problem of creation, as people understand it. We know, of course, that the universe in which we live hasn't always looked the same as it does today, that it originated about 15 billion years ago in the fiery explosion of the Big Bang. And science is able to describe the history of the universe from that intense sort of opening moment up to the present day in broad terms. I mean, there are certainly bits of the history that we don't understand very well, but there are also bits that we do understand pretty well. And so we have a story of a universe that started extremely simple. One of the reasons why cosmologists talk with a great deal of boldness about the very early universe is the very early universe is actually very, very simple. The very early universe is simply an expanding uniform ball of energy. And you really can't get a system that's much simpler than that. And that world that started so extremely simple has become very rich and complicated, diverse and varied. And far and away, the most complicated consequences of that long evolving history are you and me. We are far and away the most complicated and interesting products of the history of the universe. I have a friend called Hans Ralston, who's an American who writes on science and religion, and he says in one of his books that an astronomer peering through his telescope should remember that the most interesting thing in the universe is 6 inches this side of the eyepiece, sitting here inside our skulls. The human brain is far and away the most complicated system that we've ever encountered in our exploration of the physical world. Okay, now, you see, that's the scientific story. That's the story of how the universe has come to be as it is today. That is the story of Big Bang cosmology. Now, religion isn't competing with that story. It isn't an alternative answer to the question of how the world came to be. It is answering the different question of why the world has had that long and fruitful history. So I don't have to choose. As a scientist, of course, I believe in Big Bang cosmology. I don't have to choose between believing in Big Bang cosmology and believing that God is the creator of this rich world in which we live. I believe both, and it is perfectly consistent for me to do so. I believe that science tells me how this world has evolved, and I believe that religion tells me that that fruitful history has behind it the mind and purpose of God himself, so that something is happening in the ongoing story of the universe. His will, his fruitful will and purpose is being fulfilled. It's very important to make that distinction. So, for example, some of you, I guess, will have read Brief History of Time by my friend and former colleague Stephen Hawking. And if you got right to the end of the book, and if you have, congratulations, it is quite hard going. It's hard going because in the last quarter of the book, Steve presents his necessarily speculative ideas about the very, very early universe. And his basic idea there is that the very, very early universe, because it's very tiny when it begins, is fuzzed out by the effects of quantum theory. And indeed, it's so fuzzed out that though the universe has a finite age, it does not have a datable beginning. There isn't an instant in which it sprang forth, because everything is too fuzzy for that to happen. That's a very interesting scientific idea. It's a speculative idea. It's probably, in that form, I think, a correct idea. I wouldn't buy every detail of Steve's theory, but I think the general outline of it's probably right. Okay, but then he goes on to allow himself the liberty of a little theological speculation, and he's less good at theology than he is at physics, I have to say. He says, if there was no beginning, what place then for a creator? Now, it would be theologically unbelievably naive to answer that question other than by saying every place. Because the role of God as creator is not the one who lit the blue touch paper of the Big Bang to set it all going. The doctrine of creation, theologically understood, is not concerned with how things began, with temporal origin, as we say. It is concerned with why anything exists at all and for what purpose. And God is as much the creator today as he was 15 billion years ago. God is not a God simply of beginnings, a God at the edge of space and time. God, the true God, is at work as the creator, holding the world in being and fulfilling his purposes through its evolving and fruitful history. So if Steve's right about the very early universe, that's scientifically extremely interesting. But theologically, it's water off a duck's back, as we say. Did you use that phrase? That's an English phrase anyway, which means it doesn't really make very much difference. Ducks can take an awful lot of water off their back. So what is more interesting, actually, is to think of that long, fruitful history. What do we make of an evolutionary universe? You see, all our understanding of the universe is in terms of an evolving and increasing complexity. That's true, of course, of life on Earth. We all know that, the story of evolutionary biology here. It's also true, incidentally, of the whole universe. The whole universe is an evolving system. It started this uniform ball of energy. After it was about 1 billion years old, it began to get a little bit clumpy and lumpy, and the stars and galaxies formed, and that was an absolutely essential part in the fruitful history of the world. So right throughout cosmic history, from start to the present day, the story is one of an evolving complexity. Now, what do we make of that theologically, religiously? Well, theologically understood, an evolving universe is a universe which is allowed by its creator to a certain extent to make itself. You see, God's gift to his creation is to allow it to be itself. The gift of love is always the gift of an appropriate measure of freedom. We know that with our children. As our children grow up, they have to be allowed to be themselves, to do their own thing. There comes a moment when little Johnny has to launch out into the dangerous traffic on his bicycle alone, because that is the necessary and costly, I might say, gift of parental love, to allow him to be himself. God, in a similar way, gives a freedom to his creation. He allows it to be. He endows it with fruitfulness. He keeps it under his providential care, but he allows it to explore and realize its God-given fruitfulness. An evolutionary universe, theologically understood, whether we're thinking of the stars and galaxies, or whether we're thinking of life here on Earth, is a universe that is free to make itself. And that's a very positive and, I think, helpful thought about the history of this remarkable world. That's the first thing I want to say. It's a little bit about the doctrine of creation. And I hope that what I've said there illustrates for you, a little bit anyway, how there is a fruitful interchange between the scientific insights we have about the history of the world and the religious understanding that we have of what's going on, what is the meaning of that history. They're not at war with each other. They are in a friendly relationship with each other, as I shall discuss in much more detail when I give my lecture tonight. Another very interesting thing is going on at the moment. You see, when scientists look at the physical world, they're very struck by the beauty of it all. Doing science is a fairly wearisome sort of activity, isn't it? Every worthwhile activity is. There's a great deal of routine in doing science. There's a great deal of frustration, you know, good ideas don't work out, and that sort of thing. That's true in any career. It's certainly true in science. I was a theoretical physicist. I was a sort of paper and pencil chap, and at the end of a typical working day, my waste paper basket was full of crumpled bits of paper. As you know, the morning's good idea didn't prove to be quite so smart when you looked at it again in the afternoon. So why do we stick at it? Not for the pay, for sure, actually. Why do we stick at it? We stick at it for the reward that comes to us, the feeling of wonder. I've never met a scientist who wouldn't want to speak at some stage of the feeling of wonder that one has at the very beautiful structure of the physical world that is revealed to our inquiry. For a theoretical physicist, that particularly reveals itself in the fact that the equations that describe the fundamental structure of the world are always economic and elegant in their character, are always endowed with that unmistakable property of mathematical beauty. Some of you will know about mathematical beauty, others of you may feel slightly doubtful about that property, but believe me, as one who speaks the language, it is a very recognizable thing, and it's a very striking fact that the fundamental equations of physics always have this unmistakable character of mathematical beauty. The greatest theoretical physicist I've known, greater even than Murray Gell-Mann, was a chap at Cambridge called Paul Dirac, who was one of the great founding figures of quantum theory. And he said once that his whole life, and it was an amazingly fruitful life as a theoretical physicist, his whole life had been based on the search for mathematical beauty in equations, with the expectation and indeed the fulfillment that those beautiful equations, when found, would prove to be the ones that describe the world in which we live. Now, what do we make of that? It's a very striking fact about the world. You see, what I'm saying to you is that as we study the physical world, as we study just the bits of matter out of which the physical world is made, we see the structure and pattern of all that shot through with mathematical beauty, shot through, I would want to say, with signs of mind. The physical world looks as though there is a mind behind it, expressed in that beautiful pattern and structure. And of course, as a religious believer, I say, yes, that's right. It is the capital M mind of God that lies behind the rational beauty and order of the world. Now, that's the sort of thing that encourages scientists, not just pious scientists like me. I mean, you would expect me to take that sort of view, wouldn't you, really? And I've always been part of the worshipping, believing community. But it also strikes very strongly scientists who don't have any particular time for traditional religion. You've had Paul Davis here in Portland a while ago. Paul's a friend of mine, and we often talk to each other, and he really thinks conventional religion is disastrous. I don't, of course, agree with him about that, but he is also struck with the rational beauty of the world and feels it is a sign that there is some intelligence behind it all. And it's more striking, really, that he thinks that than I think that, because, as I say, I'm naturally inclined to think that way. And then there's something else we've realized about the physical world, which is important too. I've talked about that fruitful history, that the world started very simple and has become very rich and complicated. Now, that in itself is very remarkable, but even more remarkable is a realization that's come to us gradually, but with increasing and irresistible force in the last 30, 40 years, I suppose, that rich evolving complexity is only possible in a physical world that is very special in its characteristics. It is very finely tuned, I think one could say. In other words, it wouldn't happen in just any old universe. Now, what do I mean by that? What I mean by that is this. We can scientifically, we can specify our universe by saying what sort of laws of nature we see operating in it. So, for example, we say, okay, we've got a universe here which has got a law of gravity. It's an inverse square law of gravity. Not only do we say that, but also gravity has a certain strength to it. There's a certain intrinsic strength of the gravitational force. It's actually, it turns out, a very weak force. It might surprise you to think that's so, but the way we think about these things, gravity is actually rather weak. But we can imagine, of course, a universe in which gravity was different. It might be even weaker, or it might be a bit stronger. And we play sort of little intellectual games and think, okay, well, I wonder what the history of the universe would be like if gravity had, say, been twice as strong as it is today. Well, my first guess would have been that that wouldn't have made all that much difference. I mean, if gravity was slightly stronger, we would all be slightly shorter. Because, you know, if gravity's stronger, you can't grow quite so high. So it might have been full of people of 3 foot rather than 6 foot, but you wouldn't have thought it would have made very much difference apart from that. That would have been my guess, and I think that would be the guess of most scientists. But as we've come to look at the process, we find that isn't so. That in fact, if gravity had been significantly different from the way it is, and indeed if any of the fundamental forces of nature had been different from the way they are, then it wouldn't be a question we'd be 3 foot rather than 6 foot. There wouldn't be any people at all. It is only a very finely tuned world with very, very specific laws and forces in it, which is capable of having an evolving history that produces something like you and me. That's a very surprising result, but it's something that's been forced upon us. Let me just give you one tiny, tiny example of the sort of considerations. I won't talk about gravity, I'll talk about the nuclear forces. You see, one of the things you've got to do if you're going to have a world that produces life, you've got to have the raw materials for life. The raw materials for life are the chemical elements. So you've got to have all the chemical elements, and in particular, you for sure got to have carbon. Carbon is a very important element. The chemistry of carbon is the thing that produces all that complexity I don't know much about chemistry, but it produces all the complexity of molecules that enables life to come into existence. So you've got to have carbon. Where are you going to get it? Well, you won't get it in the early universe. The early universe is very hot and has nuclear reactions going on, but it's very simple too, so it only does very simple things, and carbon is too complicated to be made in the early universe. So you've got to make it somewhere. Where are you going to do it? Well, the answer is you're going to make it, if you're lucky, you're going to make it inside the stars. See, when later on the universe gets a bit lumpy and the stars condense, the stars heat up, and they burn because of the nuclear furnaces that are burning away in their interiors. And it's in those nuclear furnaces that carbon is made. Every atom of carbon inside your body was once inside a star. We're all made from the ashes of dead stars. We're people of stardust. Now it turns out actually that it's very tricky to make carbon inside a star. You require a very precise level and organization of the nuclear forces to bring it about. So that would be one thing that would go wrong if you change the force of the strength of the nuclear forces. You wouldn't make any carbon. And there are many, many, many considerations of that sort. I could really talk from now until noon about those things, but I won't do that. You'll, I'm sure, trust me that I'm correct in saying that. So we have this amazing insight, quite unexpected, that the world, in order to be fruitful, is not just any old universe. It is a very special universe. It is a universe in a trillion, peculiarly and exactly finely tuned in its given scientific laws and circumstances to make it possible for us to be here. What do you make of that? Well, of course, as a religious believer, I can make something of that. Scientifically, I haven't anything to say, because scientifically, I just have to take the laws of nature as they are. Science doesn't explain the laws of nature, it just takes them as they are. But I'm saying to you that that finely tuned fruitfulness seems to me not something one should take just as it is. One should look for an explanation of it. And of course my religious insights provide me with just such an explanation. For my religious insights tell me that indeed I do not live in any old universe. I live in a universe which in its finely tuned fruitfulness is a creation of God the Creator, who has endowed it with precisely those exact laws and circumstances which will enable its evolving history to be fruitful. It's a sort of, it's a sort of, people sometimes say it's a sort of anti-Copernican revolution. You see, we learnt that in the 15th century that we don't live at the center of the universe. We just live in a, no, we don't have any particular address in the universe. We just live in a sort of side street somewhere else. But now we realize that though we don't live at the center of the universe, the whole character of the universe, the whole scientific description of the universe is precisely adjusted to make it possible for us to be here. I think that's a very striking fact. I just take one other example of the interaction between science and theology that's going on at the moment in a way that seems to me very promising and worthwhile, something I'll be particularly talking about with some of our other friends here on Saturday evening. People often think that the scientific description of the universe is the description of a universe that is really just a gigantic piece of mechanism. That scientists think of the universe as if it were an enormous piece of cosmic clockwork, so that the only fitting God one could think of in relation to such a clockwork world would be a god who is simply a sort of cosmic clockmaker, who perhaps designed the clock and wound it up and now just lets it run along. And there's no doubt that the science of the 18th century, following on the discoveries of Newton, and in a somewhat different way, but essentially similar way, the science of the 19th century really did think about the universe in a mechanical way. Now, one thing I want to say to you, as strongly as I can, is that 20th century science has seen the death of a merely mechanical view of the world. It's seen the death of a merely mechanical view for two reasons. One, of course, is the cloudy, elusive fitfulness of quantum theory that, enormously to our surprise, we have found lurking at the atomic and subatomic roots of the world in which we live. The quantum world is I've worked all my life in quantum physics. The quantum world is very strange and unexpected. If you have a quantum entity like an electron, if you know where it is, you don't know what it's doing. If you know what it's doing, you don't know where it is. It's a strange, unpicturable world which is loose in its structure. That in itself is very interesting. Perhaps the greatest revolution in physics since the 17th century. But that's really sitting down there at the subatomic roots of the world, rather small-scale stuff. In the last 30, 40 years again, we've realized that even the everyday world, even the everyday world of our direct experience, our picturable experience, which we thought was so well described by Newton, is in fact not mechanical either. You see, chaps like me who learnt about the physics of the everyday world, classical physics as we call it, learnt about systems like steadily ticking pendulum. You have a steadily ticking pendulum, that's a classic problem. Or you have a planet going around the sun, that's a steadily going around the sun, that's a classic problem. Now those problems are very simple and they're very robust. By that I mean that if I have a steadily ticking pendulum and I slightly disturb it in some sort of way, okay, if I give it a slight disturbance, I slightly change its motion. Nothing very dramatic happens. So a pendulum like that, which doesn't get put out of kilter by small disturbances, is robust, it's predictable, it's controllable, it's mechanical, in a word. And we thought that that's what Newtonian physics, the physics of the everyday, that's what we thought it was like. But we've come to realize that actually almost all the world of the everyday doesn't consist of clocks, but consists of clouds. That most everyday dynamical systems are in fact so exquisitely sensitive to circumstance that they are intrinsically unpredictable, that if you slightly disturb them, their motion is completely changed. Something entirely different happens. It's very surprising. That's absolutely, again, an astonishingly surprising discovery. It's called chaotic dynamics, a very bad name, I might say, but it's called chaotic dynamics in the trade. And people refer to it as, you won't be surprised to learn that one of the early discoveries in this area was literally concerned with clouds, was concerned with attempts to understand the Earth's weather. And in the trade, this exquisite sensitivity is sometimes called the butterfly effect. That the Earth's seas and atmosphere, the weather systems of the world, are so sensitive to circumstance that a butterfly stirring the air with its wings in South America today will have consequences for the storm systems over Portland in 3 weeks' time. I can tell you, long-term weather forecasting is never going to work. It's you knew that already, of course. The weather systems are intrinsically unpredictable. We can't know about all those butterflies in South America. So we've learned that a great deal of the physical world, at the everyday level, is unpredictable and therefore open in its behavior. We live in a world that whatever it is certainly not merely mechanical. It is something more subtle and more supple than that. Now that's a terrific gain for physics, mind you, because physics begins to describe a world of true becoming, a world in which really new, really novel things can come about. It begins to describe a world of which we could conceive ourselves as being inhabitants. It begins to describe a world whose open future helps us to understand our powers of action, of agency, of bringing things about. If the future is not fixed, then we have a power to change it, to execute our will and intentions. Of course, we've always known we had that. I'm not telling you that somehow you've only discovered your have powers of choice and responsibility because of chaotic dynamics. We've always known we had that, but now we begin to understand how that's consistent with what physics tells us about the world. Physics begins to describe a world in which we can act, and I also believe, and I haven't time to elaborate this now, but this is the commercial, my book Science of Providence goes into this. I believe that a world that is open in that way and in which we see ourselves as acting is also a world in which God is able providentially to interact with it. So I believe that I can take my science absolutely seriously and not only believe in the God who is the creator of the world, who holds in being this wonderful and richly fertile world, but he is also in continuous providential interaction with it. I sometimes give a talk called Can a Scientist Pray? And my answer to that is absolutely yes, he or she can. Well, I think I've talked for long enough. I hope I've given you some idea of, first of all, the need that we have if we're to really understand the world. We need the insights of science. We need also the insights of religion. We won't get a satisfactory understanding unless we have the two. And I hope I've also given you some idea of how, in fact, those insights, quite far from being in conflict with each other, complement each other, and how there is an important and fruitful and encouraging and very active interchange between the two, helping us to find a deeper understanding of the world in which we live. When I became a clergyman and turned my collar around, as we say, my life changed in various ways. I was in parochial life for about 5 years, and it was very different being a curate, tramping the streets of a large working class parish in Bristol, which is how I began my career as a clergyman. My life was very different from having been a professor of mathematical physics at Cambridge. My life changed in various ways, but there was one thing that didn't change in my life, both as a scientist and as a clergyman. My life is concerned with the search for truth. That's the essential question for all of us. And I believe that I can hold together my scientific insights and my religious insights, not without some puzzles, of course, but without dishonesty, without compartmentalism. I don't want to be a priest on Sundays and a physicist on Mondays, and also with considerable mutual agreement and enhancement, and that together they strengthen my search, that unending and necessary search on which we're all engaged for truth about the wonderful world in which we live. Thank you very much. Thank you. We've a bit of time left, and if you can stay, perhaps we can have some sort of conversation. Over there.
Yes, Dr. Polkinghorne. I believe it was Fred Hoyle who said the universe is less like a great clock than it is like a great mind. I believe that's an
That might well be so, yes, yes.
Can you give us some insight into how he rationalizes that and the fact that he has no religious belief at all?
Well, actually, that's a very interesting story. Fred Hoyle, again, is an old friend and colleague of mine. Fred, as a young man, was very militantly against religion. He gave a celebrated series of lectures on the BBC in the late 1940s about cosmology, really, but he allowed himself to make a few disparaging remarks about religion in the course of them. And now Fred is another of these people who, as his life has gone on, as he's thought more about the world, has begun to think that there's more going on than he had originally recognized. And Fred, he recently wrote a book called The Intelligible Universe. It's I might say it's a very rum book and has some very odd ideas in it, in my opinion. But nevertheless, again, he believes there is some intelligence that lies behind the universe. And he's another Paul Davies, if you like, none of these people. You see, I think that the academic world, which is the world I know the best, the academic world has lots of people in it who are in some sense wistful fellow travelers with religion. They can neither quite take the idea of God, anyway in a traditional sense, nor can they leave it alone. They would like a religious faith. They think there are things about the world that suggest there's something going on behind it, but they're afraid that a religious faith would involve some form of intellectual suicide if they embraced it. What I want to say to them is
laziness.
well, no, I don't think it is. I don't think it is, actually. What I want to say to them is that it doesn't involve intellectual suicide. In fact, you have to love the Lord your God with your mind as well as every other part of you. What they don't see, they will think of some sort of intelligence behind the universe, but they will often say, I see no sign of the personal God of the Jews and Christians and Muslims and so on. And I would say to them, no, of course you don't. You're looking in the wrong place. You're looking at the impersonal experience of the physical world. Science is impersonal activity. If you want to meet the personal God, for me, the God and Father of our Lord Jesus Christ, you've got to take the risk and the ambiguity of looking at personal experience. So I'm always trying to persuade them to say, you know, read the Gospels. What do you make of that strange commanding figure that you see there? So I think there's a lot of sort of questioning going on. I mean, it's a very interesting question, for instance, to ask, why does God keep on popping up in a brief history of time? A brief history of time is simply a book about physics, about cosmology. You could perfectly satisfactorily write that book without mentioning God at all. And in fact, God is not in the index, but he is in the book. Well, I think there's some sort of internalized debate reflected by that. Lady at the back.
Malcolm Muggeridge
Yes?
said that we are in a post-Christian world,
Yeah.
mainly because we have truth is, instead of being objective like it has in the past,
Yeah.
subjective.
Yeah.
And so therefore we are also in the demise of Western civilization as we know it. Would you comment on that?
Well, in some sense, I started off by saying something rather like that we live in a world where people see matters as being matters of opinion. They're very respectful. They say, I'm sure it's true for you, and I respect you for your opinion. Now, I'm just not interested in that. And I think I have to say to my friends, I want to try and find things that are true, period, without qualification. That is, you see, a religious belief may help one to face life, or indeed to face death. But it can't really do that unless it's actually true. It isn't just a technique for getting from breakfast to supper. It's a search for the foundational truth about the world. So questions of truth are, it's true that the spirit of our age is an age which is not so concerned with questions of truth. That's, of course, not a new phenomenon. Christianity came into being in the first centuries of this era, and the world of that time was very, very like the world of today in many ways. It was a world of plural faiths and plural understanding. It was a world with a great deal of despair, both about what the future held and also about being able to settle questions of truth. I often think when I read about the early centuries how similar they are to the centuries today. We've got used to the idea of the centuries of Christendom. But that's a long but historical episode. Now, the early church, of course, grew and flourished and eventually took over that ancient world. We shouldn't be too despairing about the world in which we live. If we believe that we have seen something of the truth, we must hold fast to that and seek humbly but persistently to convey that to our friends and neighbours.
Doctor,
I've got to let this chap here have a go, and then I'll...
Yeah, you started out the lecture by saying you was in this laboratory and you saw an overlay of these on.
Yeah.
And don't you have to do the same thing with your religious beliefs?
Yes.
You have to put an overlay
Yes.
and interpret that.
Yes, absolutely.
And isn't that the difference there, though? Isn't the fact that you can, in that laboratory, they will test this overlay, and can you test the overlay that you have?
Well, that's a very good question. Everybody hear that? The question is, okay, in science we have the power of testing. What's the corresponding power in religion? Well, I think the answer to that lies in recognizing that science is essentially dealing with an impersonal aspect of the world, dealing with the world as an an object. And we have then the power of experiment. We kick it around, we pull it apart, we do all the things that our experimental colleagues are up to. But we're very well aware that there are absolutely important aspects of human experience, deeply important and deeply real aspects of human importance, where the power of testing has to give way to the power of trusting. How do I know that you are my friend? If I am continually setting little traps to see if you are my friend, I have my hair cut and you say, John, you're looking rather smart and so on today, and if you don't say that, I feel, gosh, you don't really care about me. If I set little traps to see if you're my friend, I shall destroy the possibility of friendship between us. Because friendship between us, our knowledge of ourselves as persons, is not based upon testing, upon trusting. Now that trust, of course, is the ground and the true ground of our belief. I mean, how do you know your wife loves you and so on? Well, of course, it's not unmotivated belief. If I come home night after night and I find that Ruth's gone out and there's nothing for me to eat, I begin to wonder. I'm glad to say I don't have that experience. But it's motivated belief, but it's belief that's based upon trusting. So I think that's the answer, that we're in a realm of experience where there are means of checking things out, but they're not through putting things to the test, they're through the commitment of trust. Now,
Can I just make a quick comment on that? That in the philosophy of science, there is two trains of thought that go along in that, and that when say testing normally in the completely detached physical sense, it's what's called the detached observer model of what inquiry is. And there's a flip side to that, which is being called the participant observer. And you find it a lot in the social sciences, because in the social sciences you can't detach. You interact, you're consistently interacting with the system that you're trying to study. So either the social scientists found themselves in a considerably compromised position when they tried to be like physical scientists, okay? What you do is you find they are complementary modes here, and so that they find that you can't actually how can you go enter into a primitive society, interact with that society, learn something without running into this problem of influencing them and not seeing the right thing? Well, you can't solve that problem, basically, in the detached modes. It's an unsolvable problem because you're interfering with the system in a way that you can't dampen out. But then they say, does that mean there's no knowledge? Does that mean there's nothing we can learn in that system? And the answer is no, that it's developing in this direction. And I think it leads very directly to
absolutely.
Yeah. It leads to different kinds of premises and a different type of knowledge in a sense. And you are in a creative, inventive mode as well as being in the detached mode. But they are certainly clearly two senses of learning going on here, and two senses of knowledge that are very, very credible and very well founded.
Well, yes, I don't know whether you caught the question. The question is that, of course, Easter is just over a week away when we are thinking of the resurrection of Christ. I want to say, first of all, that my own Christian faith depends centrally upon the belief that Jesus was raised from the dead that first Easter day. You see, the one thing that's really strange about Jesus Christ as a religious leader is the end of his life. Most of great religious leaders, Moses, the Buddha, Muhammad, end their life in honored old age. Jesus dies in middle age, deserted, a painful, dark death. It's a very, very strange ending. And you might think that would have been the finish to the whole business. But something happened, because within a few weeks those same disciples who ran away so cowardly on Good Friday are popping up and saying to the same authorities who seem so threatening, this man Jesus is God's key to everything. He's God's Lord and Christ, is the way they express it, and he is alive again. Now, that's an amazing event. Something brought it about, and I think it was the resurrection of Jesus. Now, I believe in the resurrection as part of this motivated belief, and I could easily talk for an hour about what I think is the historical motivation for believing that amazing and unprecedented event took place. But I don't have the time to do that, obviously. But I believe that the resurrection makes sense, A, because it vindicates Jesus. It was not fitting that his life should end in darkness and misery. And secondly, it vindicates God. That God did not wholly abandon the one man who committed himself to him. And thirdly, it vindicates that hope that we all have within us, that this life is not the whole story. Somebody once said, there is a deep human longing that the murderer should not triumph over his victim. And that's right. But it will only be right if there is a destiny beyond death. And I think that the resurrection of Jesus is the foretaste and the guarantee of a destiny beyond death for all of us. Now these are very big issues, but I'm glad to have the opportunity of saying something about them. I think I'll go over here. Yes, this gentleman here.
How do scientists, either of faith or not of faith, cope with what happened before the Big Bang?
Well, the answer to that is they say, as Augustine had said 13 centuries before, that there was no before. You see, modern science understands that there is an intimate connection between space and time and matter. It's a sort of package deal. If you have one, you have to have all three. That's the general theory of relativity in a nutshell. If you all the rest is commentary. So when the world came into being, time came into being with the world. So there is no before. God, of course, is eternal. God is outside time and everlasting in that sense. But Augustine, said that God did not create the world in time. He created the world with time. So that's how we cope with it. There is no before. You may not find that a satisfactory answer, but it's the best I can do. And if you ask the question again, I shall go red in the face and bang the desk and say that's the answer. Gentleman over here.
What is, in your view, the role of religious dogma from one religious group to the next? How does that fit in your particular view of dealing with the scientific issue and dealing with creation, etc.?
Yes. I see religious dogma not as being a set of unnegotiable propositions that are revealed in some sort of mysterious and unquestionable way, and which are presented to you in a sort of take it or leave it way, sign here and the dotted line at the bottom of the page. I don't think that religious truth is like that. I see religious dogma, and there's something like, let's say, like the Christian creeds, which summarize the essence of Christian faith. I see them as exactly doing that they are sort of summaries of the insights that have come to the Christian community through its Christian experience. Therefore they're rather like the sort of summaries of scientific theories that you find in textbooks, which again are not there on a take it or leave it basis, I've just said there, space and time matter are, but which are summaries and distillations from actual experience. So what I'm trying to say is this: as a scientist, my instincts are to be what one might call a bottom-up thinker. That you start with the phenomena, start with the things that happen, and build up your understanding from that. I'm not a top-down thinker. I don't sail in from the top with certain general principles that I feel I know, and then work out everything in terms that I work upwards. And I do that scientifically, and I think I do that religiously as well, and I think that's a perfectly possible way of doing it. Now, there is, of course, a very great perplexity in the existence of the different religious traditions of the world, that my friends in other religious traditions are clearly seeking to do the same thing, but they reach rather different conclusions. And that is a real puzzle and a very important problem, and I don't have any very simple thing to say about that. Yep.
It seems to me that in the Judeo-Christian theology, there's a presupposition of a separation of God and the universe.
Yes.
These are two different things.
Yes.
It's obviously directs theology along a not predetermined but very narrow path. In physics, there's you obviously know about the anthropic principle of cosmology.
Yes.
That the universe is what it is because we are who we are.
Yes, I did describe. Well, I think we are who we are because the universe is as it is, actually. But that's the other way around.
Yeah, but can you talk about the idea of God being outside the universe?
Yes. That is one of the interesting differences between different religious traditions. You're quite right in saying that the Judeo-Christian and also Islamic tradition see God as being distinct from his creation. He creates, in God's loving act of creation, creates something other than himself. He allows something other than himself to be. Now, there are other religious traditions. I don't understand the religions of the Far East very well, but as far as I read them, they are much more prone to integrate, to have a monistic view, as people say, so that God and the world are more closely identified. I have to say that to me, it's an attraction in Christian theological understanding that it is based upon the separation between God and his creation. And let me say two reasons for that. First of all, one of the great problems, of course, in any religious understanding is the problem of evil and suffering. Why is there so much evil and suffering in the world? I don't need to explain what that problem is. We're all aware of it. The more closely you identify God in the world, the more difficult that problem becomes, the more ambiguous God himself becomes in his moral stance, it seems to me. The other thing is this: I think one of the absolutely fundamental human intuitions, and that undergirds the reality of religion, is that despite the suffering and strangeness and bitterness of this world, there is a very deep human intuition of hope. The American sociologist of religion, Peter Berger, draws our attention to a woman comforting a frightened child in the night. She goes to the child and she says, "It's all right." And Berger says, what's she up to? Is she telling that child a loving lie? Because if you look at the world, it doesn't really look all right. He says, no, she's not. There is some fundamental human intuition that despite the bitterness of this world and all the perplexities that brings to us, in the end, all will be well. I think that's right. I think that there is a deep human intuition of great significance. Now, the God who is other than the world, who sustains the world and is certainly in interaction with it, but who is other than the world, can be, and is in my view, the true ground of hope. But a God who is closely identified with the world is more doubtful as the ground of hope. This universe is going to decay or collapse on a very long time scale. The more closely God is identified with the world, the less he seems able to be the ground of a truly lasting hope. So for me, it's that Near Eastern religious intuition of the separation between the Creator and creation is actually very important and necessary to making sense of theological reflection. Where are we? Over there.
Cybernetics is the field that I practice, and we're dealing with goal-oriented systems
Right.
and purposive systems. I tend to deal with human systems. And to get back to this question of the perceptual overlay one might put on.
Yes.
The problem that those of us in my field constantly face is the teleological trap. I wonder if you could shed some light on how you as a physicist avoid that trap.
Can you just say in a sentence what you think the trap is?
What we're having to deal with is a tendency, because of our religious and spiritual upbringing, conditioned responses, expectations, and hopes, is to have a God-oriented goal or purpose for all the systems that we study.
Yes. I think we should give way to that temptation. It seems to me a very reasonable thing to do.
We're told as scientists not to do that.
Well, we're told that methodologically as scientists. That's the method of science, is not to invoke reasons of purpose. But you see, teleology it's a bit like stuffing a balloon into a cardboard box that's too small for it. You push it in one side, it comes out the other. And teleology has a way of popping up. I mean, I talked about the anthropic principle, about the fine-tuning of the universe. That sounds a very teleological insight in a way. And I think we should let the chips fall where they will. But I do think, you see, because I think religion is primarily concerned with questions of meaning and purpose, we will be blinding ourselves, we'll be closing our religious eye if we don't allow ourselves to look at the world partly through interpretations involving purpose. So I'd say give way to the temptation.
Could you expand that a little bit on what you talked about natural theology reemerges? Wouldn't that tie into what she's saying? I mean, can we get that going again?
Well, I think in a way we don't need to get it going. I think it is going again, actually. It is bubbling away. I think we're getting fairly near the close. I think I'd like to give this lady here a chance. She's been very patient.
By your idea that your statement that all the carbon in our bodies came from a star.
Yeah,
but
yeah.
I have a very limited scientific background, and I'd like to know something about the itinerary.
Well, that's a very reasonable question. Stars live on average for about 10 billion years. And stars began to form probably when the universe was about 1 billion years old. So when the universe was about 10 or 11 billion years old, stars were, the first generation of stars was coming to at the end of its life. And they had made lots of carbon inside them. Now, of course, if it's locked up inside the cooling core of a dying star, it won't be much use. But another condition for a fruitful universe is that you must have some stars which, as they die explosively. We call them supernovae. So that instead of just dying away like that, they have a great explosion. That scatters the elements that they've made, the carbon and all the other things they've made, into the environment round about. It goes floating off. Gravity is at work all the time. The effect of gravity is always to pull things together, to make things snowball. So a second generation of stars and planets begins to form, made out of the debris, the condensed debris of the first generation. But that debris is now different. The first generation were just made of hydrogen and helium, and the second generation will have all these elements that have been made inside these supernovae. So what happened was there was a star that made the carbon, the star exploded, the carbon condensed here onto this little planet Earth, that helped to produce the chemical environment in which eventually, after a billion years or so of terrestrial history, enabled replicating molecules and elementary life to begin, and that's where the carbon inside you comes from. Okay.